Hello, and welcome to Summarize Science, where we break down fascinating new research. Today, we're talking about one of the biggest mysteries in the universe, dark matter. Scientists run deep underground experiments to try and catch a glimpse of these elusive particles. Now, we usually think of dark matter as weakly interacting, meaning it passes through normal matter like a ghost. But some theories suggest it could interact much more strongly, especially if the dark matter particles are very light. In this scenario, dark matter particles from space would actually bounce off the atoms in Earth's atmosphere and crust before reaching a detector. This leads to a really cool and distinctive signature. As the Earth rotates over 24 hours, a detector on the surface is shielded by different amounts of the planet. This means the dark matter signal should get stronger and weaker in a daily rhythm, a phenomenon called daily modulation. Finding a signal that beats to this daily drum would be powerful evidence for dark matter, because normal background noise shouldn't behave that way. However, calculating these Earth scattering effects is incredibly difficult. It requires massive computer simulations that track countless virtual particles, which is extremely slow and expensive. That's where this paper comes in. The researchers have developed a new, much faster way to calculate these effects, which they've implemented in a code called Vern2. It's a semi-analytic method, which is a fancy way of saying it uses clever math equations as a major shortcut. Their method simplifies the complex journey of a dark matter particle. It assumes that when a particle scatters, it doesn't lose energy and is essentially reflected straight backward. By considering only particles that scatter up to 2 times, they can get an answer much more quickly. But is this shortcut accurate? To find out, they compared the results from their fast Vern2 code against the gold standard, slow, and detailed simulations from another program called Damascus. The results are frankly stunning. On these plots, the solid lines are their new fast method, while the points represent the results from the slow, intensive simulations. As you can see, for a wide range of scenarios, they match up remarkably well. This plot shows the actual event rates that an experiment would look for, changing based on the direction the dark matter is coming from, which corresponds to the time of day. Again, the Vern2 model provides a very good approximation of the more complex simulation. Overall, their new method is accurate to within about 10 to 30% for the scenarios of most interest to current experiments. That's more than good enough for signal modeling, but here's the kicker. This new formalism is about 10,000 times faster. What used to take hundreds or thousands of hours of computer time can now be done in just a few minutes. So let's recap the important points. First, some forms of light dark matter might be constantly bouncing off the Earth, creating a planetary shadow. Second, this creates a unique daily modulation signal that experiments can hunt for. And third, this paper provides a new tool that makes the calculations for that hunt thousands of times faster. This is a huge deal for the field because it allows scientists to rapidly explore a vast range of dark matter possibilities that were previously too time-consuming to even consider. It's a powerful new weapon in the arsenal for scientists on the front lines of the search for one of the universe's greatest secrets. Thanks for watching Summarize Science. We'll see you next time.